Dear friends, in this video, I'm going to discuss the basic concepts of simple linear regression model that is part of regression modeling, an important topic in predictive analytics. This is continuation to the previous video that was on Introduction to Regression Modeling. What is simple linear regression? Simple linear regression involves a statistical model that is used to capture the relationship between the dependent variable and a feature or input variable by fitting a linear equation to the observed data. Dependent variable, incidentally, is also known by the term target variable. That is the one which we need to predict for a given value of the feature or predictor variable. Feature variable, predictor variable, explanatory variable, input variable, they're all used for the right-hand side of the equation. The left-hand side, y, is the dependent variable, which is a function of x, which is the right-hand side. X is a set of predictor variables or explanatory variables or input variables in the multiple linear regression. Since we are talking about simple linear regression, x is a single predictor variable. Now, what are the modeling equations? I use the acronym SLR, meaning simple linear regression. Population regression. Whenever we are doing the regression modeling exercise, mind you, we are building a model based on a given data set that is supposed to infer something exists in the population. Therefore, there is a population regression which is to be postulated by all of us, and corresponding to that, there is a sample regression based on data which is used to infer the population regression. Y equal to beta naught plus beta 1 x1 is the model that is postulated under population regression. Sample regression that is used to infer the population regression is y hat equal to b naught plus b1 x1. Both of them are in perfect linear equation manner. They are described as a linear equation. Y is the dependent variable, capital Y, and in the population regression, y is the dependent variable. In the sample regression, y hat is the estimated dependent variable for the sample data or the data set that is given to you or me to analyze. Beta naught is the intercept of the population regression model. B naught is the intercept of the sample regression model. Beta 1 is the slope of predictor variable x1 or feature x1. B1 is the slope of predictor variable x1. Here in the sample, I'm using small x1, capital X1 in the population just to say that I have observed a data set, the data set that I'm observing, to build a model that will capture to what extent the population regression model, which is postulated. Therefore, I'm using a small x1, which means it is the data set value of the predictor variable. Now, B0 and B1, how are they estimated? We have the famous statistical method of least square. B0 and B1 are the estimators of beta naught and beta 1 determined by the method of statistical least square. In the parlance or literature of statistics, these estimators are called BLUE, an acronym, which means best linear unbiased estimators. They are the best under the class of estimators possible. Sometimes we use the term estimate. Estimate is a particular value of estimator. Okay? If we have a sample data set and we find out B0 and B1, they are estimates, meaning particular values of estimators. Okay? There is a small line of difference only. Now, therefore, the behavior of the population regression is understood by the sample regression model. And both are linear, that is population as well as sample regression. You have the linear model only. That's why it's called simple linear regression, because you have only one feature variable or input variable or predictor variable on the right-hand side and both ways. That is, sample regression also has the same property, only one predictor variable on the right-hand side. Okay? Let me stop here. In the next coming videos, we will talk about how simple linear regression works in practice, containing few videos, so to say, that will clarify all the theoretical or conceptual framework which we have built in this video. Thank you very much. We will see you soon.